Using trigonometry to determine points on the unit circle. I've been thinking about this for a few days on how best to show you. So I created a bunch of pictures in Desmos, and I'm hoping this will help you understand how we might determine points on the unit circle. We are going to use our understanding of the special right triangles to help us fill in the points around the unit circle. You'll notice this is the 1, 1, root 2 triangle where the angles are 45, 45, 90. And then we have the 1, 2, root 3 triangle where the angles are 60, 30, 90. So we're going to use these two ideas on the following pages. This is the unit circle, and we call it that because you'll notice that the radius of our circle is 1. So it goes through 1, 0, 0, 1, negative 1, 0, and 0, negative 1. This is the unit circle, has a radius 1. When we're rotating around the unit circle, we begin at what they call the initial arm, which would be right here along the x-axis. So this is our 0 degrees line, and we rotate this way. To get to the 30-degree mark, this would be called the terminal arm. So we started at the initial arm and we rotated 30 degrees to get to the terminal arm. Now we want to determine the value of x and the value of y in this triangle as if we were to drop a right angle there. And the x corresponds with the x coordinate of this point, and the y corresponds with the y coordinate of this point. So you can see we go over x and up y to get to the point xy. We know the value of this terminal arm because it extends from the center of the circle to the circumference of the circle. That's the radius. And we already know that the radius of this circle is 1. So that arm is 1. We can use our knowledge of the special 30, 60, 90 triangle to help us determine x and y in our green triangle. Comparing our original special triangle here in blue with our green triangle here, it has the 30 degrees, so it'll be 30, 60, 90. And I've just pulled it out from the unit circle to look at it more clearly. So comparing these two triangles, we know that they're similar because of the 30, 60, 90. We look at the 2 of the hypotenuse here became a 1 of the hypotenuse here. So to get from this triangle to this triangle, we're going to divide by 2. So y becomes the 1 from the original special triangle, divide by 2 to get to this green triangle. And the x becomes the root 3 from the special triangle divided by the 2 to get to this triangle. So x equals root 3 over 2 and y equals a half. So our point is root 3 over 2 for the x and 1/2 for the y. That's our point xy at the 30-degree angle mark. We haven't yet considered SOHCAHTOA. If we look at the 30 degrees, SOHCAHTOA, and we label our triangle, this would be the hypotenuse, the opposite, and our adjacent. Then if we were to find x, then we do cos of 30 equals x over 1, according to this. Or cos of 30 equals root 3 over 2. Similarly, if we try sine, we have sine of 30 equals the opposite over hypotenuse, so y over 1, which equals 1/2. So for this particular point, the values are root 3 over 2 and 1/2, but for any particular point, we can determine the x value by using the cos of the angle and the y value by using the sine of the angle. Therefore, each point on the circle has coordinates cos theta and sine theta. So our x value is cos theta and our y value for a point on the circle is sine theta. Let's look at some angles that are related to the 30 degrees. So if we were to start on the initial arm, which is here, and we were to rotate through the first quadrant into the second quadrant to this terminal arm here, that would be a complete rotation of 150 degrees. And then the related angle would be the 30 degrees that's in here, getting close to the 180 at the straight line. We learned a couple pages ago that the values for this 30-degree angle in the first quadrant would give me an x of root 3 over 2 and a y of 1/2, making this point root 3 over 2 and 1/2. We use the special triangle to determine those points. Similarly, this value here, extending from here to here, again, because it's the same triangle, only flipped over here, then this value would be root 3 over 2. However, because we're in the negative, we're going to say it's x equals negative root 3 over 2. The y is still above 0, so the y is equal to 1/2. So this point in this second quadrant is negative root 3 over 2 and 1/2. So again, from the initial arm, if we rotate 150 degrees into the second quadrant, that is equivalent to looking to the related angle of 30 degrees, and we get an x value of negative root 3 over 2 and a y value of 1/2. So this point at 150-degree rotation would be negative root 3 over 2 and 1/2. Are we seeing a pattern? Let's investigate the next one. So the next angle that is related to our original 30 degrees is now going to be 210. How did we get that? We started on the initial arm and we went around through the first quadrant, through the second quadrant, into the third quadrant. I went 30 degrees into the third quadrant so I can compare this angle with the original 30-degree angle. So altogether, I went 210 degrees. We want to determine the coordinates of the new point in the third quadrant. We remember that this point, or this x value, is root 3 over 2, but because it extends into the negative x values, it's negative root 3 over 2. Similarly, this value for y is 1/2, but because we're below the x-axis, it's negative 1/2. So this point is negative root 3 over 2 and negative 1/2. I bet you guessed that we're going to rotate into quadrant 4 on the next screen. So we begin on the initial arm and we're going to compare to the 30 degrees. We're always comparing to this original triangle of 30 degrees. And we're going to rotate through the first quadrant, through the second quadrant, through the third quadrant, all the way to the fourth quadrant until I am 30 degrees from the x-axis. So if that is true, I've traveled a distance of 330 degrees. So this angle is 330 degrees. We can fill in the values again. This value is root 3 over 2. This value is 1/2, but because we're below 0, it'll be negative 1/2. So this point, pxy, is equal to root 3 over 2, so a positive x value this time, and negative 1/2. We have looked at 4 angles in this video, and I'm going to just review. So for the green angle of 30 degrees, the point here is going to be cos 30 sine 30, and we get root 3 over 2 and 1 over 2. For the blue angle, theta equal to 150, we're going to find the same thing. We use the related angle to get that. So the 150 is related to the 30, and I'm going to get the x value of negative root 3 over 2 and the y value of 1/2, because we're still above 0 for sine. Okay, now for theta equals 210. We're in the third quadrant, and cos of 210 would be negative root 3 over 2, and sine of 210 would be negative 0.5. And finally, we're going to do 330. So our cos of 330 will be root 3 over 2, because we're in the fourth quadrant, and negative 0.5, or negative 1. I'm going to write them one last time around the circle. For the green one, root 3 over 2 and 1/2. For the blue one, negative root 3 over 2 and a half is the point. And now for 210 degrees. We're still over negative root 3 over 2 and down a half this time, so both cosine and sine are negative. And finally, for 330, we're at root 3 over 2, so positive, because it's a positive x value, so it's positive cos, and negative 1/2, because we're below 0. Those are the 4 angles related to 30 degrees. Stay tuned for more angles in the unit circle. We'll look at the ones related to 45 and 60 degrees.